Very good morning, good evening to all attendees today. My name is Chetan Konaki, and we're going to be speaking about real-world runtime benchmarking. And before we begin, I wanted to quickly lay out the logistics. We're first going to lay out the agenda, introduce the speakers, and thereafter open the conversation to a Q&A after the presentation. So like I mentioned, my name is Chetan Konaki. I'm the co-founder and CTO of ShiftLeft. And along with me is Joe. I'm going to introduce Joe in a moment. So Joe, over to you.
Thanks, Chetan. I'm Joe Seckman, VP of Pen Test Delivery at COBALT.io, and where we focus on pen testing as a service.
Thank you, Joe. So very briefly, the agenda for today's discussion is an introduction of what we're speaking about in terms of real-time benchmarking and why is this unique. Thereafter, we're going to speak in detail about the testing methodology and the application that we used as our subject to test, following which Joe will speak to the penetration testing methodology and the results yielded as a consequence of the pen test. And towards the very end, we're going to spend some time demoing the ShiftLeft application in its entirety, followed by COBALT's working process and a demonstration as well, eventually closing with Q&A. So before we begin, why real-world testing is unique? So let's touch on the subject, because often there is a symbiotic relationship between a defender, that is those that provision applications in their data centers to serve their customer needs, an attacker who's attempting to exploit that application, and a penetration tester that is essentially testing the security efficacy of that application during and before it is deployed in production. So often, lab-based testing tools that are used in order to conduct these targeted tests are lacking real-world scenarios. And what I actually mean by this is they do an effective job in bootstrapping the process to simulate real-world attacks. A good example is if you're using Burp or Zap, you essentially have plugins, and these plugins provide the facility to induce targeted attacks on the application, like cross-site scripting, deserialization, XXE, etc. Now, along with these baseline plugins or perhaps recipes to attack, there is also expertise that is brought to the table from a lab-based testing scenarios. But note that they do not emulate or cannot represent real-world attacks, because in the context of real-world attacks, you have a larger population of black hat hackers who are attempting to exploit your application with a malicious intent. And most of these tools used are baselined with recipes which are essentially learned from existing vulnerabilities published in databases, meaning that they do not have coverage from the perspective of either a zero-day or unknown vulnerabilities. The other aspect is time pressure to protect the application is increasing, meaning with the advent of DevOps, applications are deployed multiple times a day, a week, or a month. Note that the application's surface is fundamentally changing, and so is the attack surface leading on to the attack vectors. So with this fundamental change, it becomes relatively hard to have a constant set of recipes that you're applying to simulate real-world attacks.
Hey, Chetan, yes. I think the slides aren't moving. We're still stuck on the first one.
I'm sorry, we're having some technical difficulties. Just give me 1 second. I want to make sure that can everyone see my slides? Joe, can you see?
There we go. I see the agenda.
Okay, excellent. So I'm going to essentially expand the slides because we're having some problem at the moment in the presenter's view, but let me just try to move it again just to make sure it works. So can everyone see my slides now? I can just proceed in this perspective.
Yeah, that'll work. It's on the agenda slide. That's what I see.
Excellent. So let me quickly re-summarize what I mentioned in terms of why real-world testing is unique as compared to lab testing. I spoke to this a moment ago, but unfortunately the slides were not in context, so I'm quickly going to summarize. We essentially spoke as to why lab-based testing is not representative of real-world testing. We also touched on the topic that tools that are used to essentially conduct lab-based testing only represents known vulnerabilities published in databases, and the exposure to unknown and 0-day still exists. We also touched on the topic of the attacker expertise, because often there is a degree of distance between a white hat hacker and a black hat hacker. The intent is one point that stands out, but besides that, there are varying degrees of expertise and larger population when real-world attacks are applied. And finally, we touched on the point of time pressure to protect applications is increasing, simply because applications are deployed multiple times a day, a week, and a month, which means that the fundamental surface of the application is changing, and so is the attack surface upon it. So let us quickly touch on the testing methodology that ShiftLeft used in partnership with COBALT to conduct this test. There were 3 isolated teams that worked in partnership with each other to conduct this test. The first team is a development team, the team that actually built the test application and deployed 2 instances. The second team is the security team that essentially instrumented one of the applications with ShiftLeft's runtime agent. And then the penetration testing team, which was represented by COBALT, that attempted to exploit both of these applications, or both of these instances deployed. Now, the test application details corresponds to a REST-based multi-tenant application written in Java. This is a sample application that emulated real retail banking scenarios. And what I mean by that is, typically from a banking perspective, you have a register function, and then you have an add account function, move money function, log out, etc. So given that this application emulated a retail banking scenario, we intentionally induced or placed several vulnerabilities in the paths of the workflow of this application. And some of these vulnerabilities represent the top OWASP category vulnerabilities. And just to list a few, not limited to, are injection, broken authentication, XML external entities, insecure deserialization, etc. Now, in terms of the penetration testing logistics, the rules of engagement was a program brief that was created, along with which we defined a questionnaire, and a team selection was defined as well, which is based on proficiencies, availability, and geography. But I'll quickly pass to Joe to complete the logistics.
Thanks, Chetan. Yeah, and as Chetan explained, in all of our pen testing approaches, you want to make sure that you've got a clear understanding of what is exactly to be tested as far as the application is concerned. And with that, we call it the rules of engagement, or one of the first early processes within a penetration test. Within COBALT, we have a platform that we use to organize and make sure that that information is collected in a consolidated place. And we do that through 2 areas, with the program brief and the questionnaire, where we cover really important items about in-scope areas, areas of importance within the application that need to be tested, maybe some areas that don't need to be tested or tested as thoroughly, and also cover any kind of authorization that needs to take place prior to beginning testing, for example, if it's hosted on AWS cloud environment or something of that sort. Another thing that's unique with COBALT is the way in which we select teams. Our teams are a global network of freelance white hat penetration testers, and they all have varying skills and abilities and talents, which really gives us a little bit more of a pool of talent to pull from. So what we like to do, and over continuous improvement and continuous review and surveying, we keep all of our proficiencies for our researchers up to date, and then we compile a team of anywhere from 3 to 5 researchers per engagement to kind of make those proficiencies as strong as they can possibly be from a team perspective. And of course, areas with that, with the ability to scale from on a global level, we want to take into account time zones, availability, as well as geography if there's any concerns that are there. So that's the second part of our logistical approach when we're beginning a pen test. And next, one of the areas that we pride ourselves on here at COBALT is open transparency and frequent transparency of all communication, progress, status, and even retesting of findings in flight while the penetration test is being executed. So with that in mind, we set up a dedicated Slack channel for all of our tests, which we call programs, where we have the research team present, of course, the customer, as well as 2 internal teams to manage quality and just ensure that everything is going as well as it possibly can. And that's the COBALT customer success team and the SecOps teams. Once we're conducting the test, we have regular updates throughout the entire process of the penetration test, where we report back items that we found, any type of risk or in-scope questions and things like that, where we can make sure that we're really delivering the maximum value and on point with where we want to go with the pen test. And finally, through the use of our pen testing as a service platform, we use that to consolidate kind of the final status and outcome of our penetration tests. That's where all of our researchers report findings, triage those findings and assign risk values, as well as deploy the final report and track remediation status as well. So with all of those in mind, that's kind of the same approach that we use here with ShiftLeft, and I'll move over to the next slide. All right. Hey, Chetan, I'm not sure if you gave me control. There we go. And to continue our penetration testing methodology, a lot of the areas in which we maintain focus in context and quality is we have all of our testers go through a centralized VPN, which is essentially a handful of source IPs for any kind of whitelisting or any kind of validation for tester traffic against our customer's environment. And we use that data internally through a reverse proxy to manage tester activity, to kind of visualize that metric, which is pretty elusive at this point, of what does it mean to be completely covered from your attack surface perspective. So we use that, and we're continuously innovating in that space to help define that metric and both in a report format as well as visualization. So when we're setting up a program, nothing gets started until the program is set to live, which signifies the beginning of testing. And that's also the point at which researchers can report findings. Now, going more deep in depth into our penetration testing methodology, we like to cover the most common vulnerabilities that are present, which typically is the OWASP Top 10 2017 version, but also not just limiting that to items that are in that top 10. We are very well versed in issues and exploitability, so we don't use that as the concrete set of vulnerabilities we discover, but kind of use it as a guide to make sure that that's kind of the minimum baseline that's covered. And one of those ways in which we do that is also to keep track of application security verification standard notes, ASVS, which is essentially a framework that allows us to not only report areas within the application that need to be addressed from a flaw or weakness or vulnerability perspective, but also report positive attributes of the application where successful security controls may be implemented and our researchers validated as effective security controls. So essentially taking the good parts of the application along with the areas that need improvement. Now, moving on to our actual findings. Next slide.
So thank you, Joe. Yeah. Please go ahead, Joe.
Okay, sorry. Our findings and the result of our penetration test, as Chaitan mentioned earlier in the presentation, initially we started out with testing the application in an unprotected state. And what I mean by unprotected is that there's no ShiftLeft application in place to intercept or prevent any types of attacks that we're doing. So we're basically validating those 6 categories or classifications of issues that Chaitan had outlined. And we were able to indeed confirm the presence of each of these issues, which manifested themselves in varying manners, starting with injection, which happened to be SQL injection, which resulted in a data exfiltration. This of vulnerabilities that keep folks up at night, SQL injection is right near the top. So this was one that we were able to identify and point out and exploit. Next, we moved to broken authentication, where we were looking at how are cookies and headers being protected. Are they safely protecting any authenticated sessions that are present within the application, and noting any deficiencies therein that may allow a malicious attacker to combine an attack to then take that cookie and move it somewhere else, commonly known as session writing or session forwarding, or things of that nature, just to make sure that the application takes those into account. It's another area where we found a weakness and reported that accordingly. Next, we move on to XML external entity injection. And this also results kind of in a data exfiltration type capacity, which we were able to confirm and exploit as well. And the remaining issues, indeed, the same kinds of aspects of going through with areas that were identified in the application as weaknesses, broken access control, of course, in the context of the hypothetical application in a financial app, not something you want to have present, as well as more technical and deeply technical findings like insecure deserialization, or basically changing an object into a byte stream and vice versa. One key thing to note here is that there were 2 areas of the same, or 2 symptoms of the same issue. Insecure deserialization can manifest itself in a custom code base as well as a known third-party component. So we found one instance which manifested itself in a custom code base, but also we found another instance where there was a third-party component integrated into the sample application that also exhibited the same type of insecure deserialization behavior as well. And I think that's something that, Chaitan, I'm not sure if you want to expand upon that from ShiftLeft's perspective.
Absolutely. From an insecure deserialization perspective, there were 2 aspects to it which are correlated to each other. One is there was a component that was utilized within the application which contained a known vulnerability, which is a Jackson data bind library. And there were symptoms in the application that led for an exploiter to essentially induce an attack on a certain path of the application to trigger this vulnerability, which means that the input applied on that path was not sufficiently validated, which essentially led to triggering that library that contained the known vulnerability. Back to you, Joe.
Absolutely. Thanks for the refinement there. So this, in summary, really classifies the aspects of providing third-party penetration testing to verify the existence of these issues, as well as their relevance, importance through a risk and impact type rating, but also their ability to exploit and prove them as real-world issues that we commonly see in all of our engagements. Well, I shouldn't say all of our engagements. We hope not to see any of them. But these are issues that are existing in the real world and not just in a hypothetical state and scenario as we were working with this application. So moving on to the next slide, we'll cover the results of the second phase of our testing, which moved to performing findings in the, or I should say validating findings within the protected application. So with this use case, it was the same application. The only difference was that the code was instrumented with the ShiftLeft product that essentially is intended to nullify or prevent the successful exploitation of these issues that we uncovered and showed in the previous slide that they are actually there and existing. And what we can see, what I wanted to signify here in this slide with the check marks, is essentially that all of those items were successfully mitigated as a means of us validating and going back in to double check those issues. So in most of the cases, we were unable to detect the existence of those vulnerabilities once it was protected with ShiftLeft. The one asterisk that you can see there, I'm sure probably spurs some type of question. In that case, what we were able to do is identify that there was SQL injection present, but we were unable to exploit it in the same manner to exfiltrate data. And I think in the end, that's really what matters most, is the ability to exploit and put that into context with our findings. So in the interest of full disclosure, I think it's great to point that out, but still want to say that ShiftLeft product was effective in preventing the successful exploitation of probably one of the most impactful vulnerabilities within our space for several decades at this point now. So it's been around for a while. It's going to be around for quite some time after that. So with that, also one thing I wanted to point out too here is this graphic to the right outlines the reporting interface within the COBALT platform. And this is where it showcases kind of the researchers that discovered the vulnerability by the little avatar pictures, as well as the issue and severities, as well as their remediation status, pending fix in this case. So with that, I'd like to move on to the next slide, and I believe that's back over to you, Chetan.
Absolutely. Thank you, Joe. Appreciate it. So Joe touched on two parts. One part is a summary of findings in the unprotected app and summary of findings in the protected app. So let us speak from the perspective of what is protecting the app. So what you see in this illustrated diagram is a representation of how ShiftLeft is the industry's first converged solution that protects an application by informed of the attack surface and not threats. And this particular solution seamlessly integrates into the DevOps pipeline. And what you see on the far left-hand side is a technique that we have invented that analyzes bytecode and source code in order to extract a semantic graph, which represents how control and data flows in your application. And from the graph, we have built a solution that extracts a policy or a security profile, which informs our instrumented agent on the far right, which takes the onus of protecting the application from known, zero-day, and unknown vulnerabilities. So very quickly, in terms of steps, the first step is an analysis phase where we've built a very simple tool that you can insert into your build server. And the job of this tool is to extract the attack surface and the policy thereafter. Now, in process, this particular policy is used to baseline the instrumented runtime agent, which is instrumented with your production application that is deployed in production. Now, on that basis, any request that is initiated that contains symptoms of an attack is evaluated, and thereafter protection or blocking measures are taken if it has all the symptoms that leads to a potential exploit. Now let us speak in detail to what is this semantic graph all about that informs our security policy or profile. Now, often application is a composition of your custom code that is written to serve your business needs. Along with it, engineers use various open source libraries which bring forth convenience functions as they build the application. And the composition of both the open source libraries and custom code is deployed on an open source web framework or perhaps a web container. Now, when we examine the application in its composition, which is the sum of parts that I just described, it composes of various control flows and perhaps dependencies. So what ShiftLeft technology does is it takes this entire composition into consideration and extracts a graph. Because after all, your application actually looks like a graph where you have nodes representing functions and edges are where functions communicate with each other to serve a certain business need. So as we extract this graph, upon this graph, we execute a series of queries which are representative of attack detection templates. These attack detection templates are baselines that we have essentially built by examining known vulnerabilities published over the past 2 decades. Now, using this baseline, which is an exhibit of various symptoms that lead to vulnerabilities, we extract the security profile of the application. The profile is representative of all input paths of your application. Thereafter, all validation or sanitization that is conducted upon the input paths, along with various transform functions applied, and various output paths that exist in your application as a consequence of a request induced upon input paths. It reads like English language and informs our instrumented runtime agent to surgically protect the application as it is deployed in production. I'm going to quickly switch to a demo to give you a sense of how ShiftLeft works. As you deploy your application, and prior to deploying, as you build your application, ShiftLeft provides you a very simple command line tool to insert into your build server. Upon insertion, it takes as input the bytecode artifact that represents your application. And from this bytecode artifact, it generates the graph or the semantic graph on your build server and securely uploads it to your tenant in the ShiftLeft cloud, authorized by your auth token and your organization ID. Upon doing this, your application surfaces on your dashboard on the ShiftLeft SaaS application. So to give you a quick sense of how your application looks from a perspective of its attack surface, ShiftLeft transcribes all input paths in your application that you see on the far left-hand side of your screen. Given that this is a typical web application, we have various web routes serving the business needs of a particular consumer. Now, as a consequence of triggering an input on the source, various destinations are created as a consequence. Now, often when we build applications, engineers want to log data in order to understand and triage and observe control flow through the application. So this is an example of a log file created as a consequence of a particular route being triggered. And in certain cases, you have the application communicating outbound with various other microservices. So what you see on the far right-hand side is a representation of all outbound communication from an application perspective. Now let us click through one particular vulnerability that has been identified by ShiftLeft. This is an example of a command injection where an attacker controlled data has been applied upon a particular route without undergoing validation or escaping. Now, on quickly examining this particular alert or triage information, I want you to draw your attention to certain areas of this particular screen. The area where I'm hovering on my mouse is all relevant information pertaining to your code that was analyzed by ShiftLeft. Note that we are able to identify the Git or Team Foundation server or any SCM commit ID. Along with it, we have the runtime information pertinent to when the exploit was applied and how many times the exploit was applied. Then we plot information pertinent to the data flows, meaning which particular attribute was injected into the request payload, which led for this exploit to manifest. And at the bottom of the screen, we have a stack trace, or perhaps your control flow and data flow described. Now, this piece of information is critical because when a threat is induced upon your application, often it's very hard for engineers to correlate at which point that the vulnerability caused this threat to be induced. So ShiftLeft provides a converged view of both the threat and the vulnerability. So with this information, it makes it relatively easier for engineers to triage this particular incident with proof of exploit, pointing to the line of code that led to the exploit. So this significantly reduces the mean time to repair or resolution from a typical patching perspective. But until engineers apply this fix, the ShiftLeft agent can be enforced in blocking mode to block any more attacks induced thereon upon the application. I'm going to switch back to the presentation and hand over to the COBALT crew to speak about their product. So over to you, Joe and David.
Okay, so I'm David Mirian. I'm an account executive at COBALT, and I'm going to give you a static description of how COBALT approaches pen testing. You've already had a chance to hear from Joe and the interaction that COBALT had with ShiftLeft, and so I'm going to be mindful of that and keep that short. So the easiest way to think about COBALT is that we do penetration testing as a service, gray box and black box manual penetration testing. So what exactly does it mean to be doing pen testing as a service? I think from the next slide, we can have an illustration of that. So if you would please, thank you. So the traditional approach to a pen test is done from a management consulting business model. And there are some disadvantages from that approach that COBALT has found ways to amend and drive greater efficiencies for the development team, for the company that's having the pen test done. And we found that using a software as a service business model creates and drives those efficiencies from the pen test. So what does that mean? That means in a COBALT pen test, instead of just getting a PDF, a static 40, 50, 60 page document that your team has to break apart and go through, COBALT puts the findings onto our platform. We connect to Jira and GitHub, so you can push that, generate a ticket, get the information efficiently and effectively. And I'll show that in the next slide in just a minute here. Furthermore, as Joe described, to an extent, we're pulling from a team of experts worldwide, and we're able to therefore schedule a pen test in as little as 24 hours. So what you would see on our platform here, this would be, so earlier you saw from Joe was showing the listing of all the vulnerabilities. In this screen, this is what you would see when you would click through. And so I'll go through a little of this. Essentially, it's a description of the vulnerability, the criticality rating, which you see on the right side, the connection to Jira. So all the information is there for you to easily see. And if you were able to scroll below from this slide, if it were actually our platform, if something weren't clear, you could just ask a question of the tester while the tester is going on, get clarification, what does the suggested fix mean, and so on. So it's a much more collaborative and dynamic process as the pen test is going on in comparison to the traditional test where it's a bit black box. You wait till the PDF report in the end. In COBALT, it's live, it's happening, it's immediate. And as you'll see in the next slide, it shows a bit of our analytics. This is another way to be able to triage. So the left side, excuse me, is the analytics component that is included in COBALT's platform. The thing to remember here, this is a bit of just a high level view. I'm happy to show anyone more about COBALT who's interested. You can check that out from our website. But furthermore, on this left side of the screen, all of those analytics, those charts, if you will, are clickable, they're dynamic. So we essentially, a way to think about triaging with COBALT in comparison to having to go through that 40, 50, 60 page static PDF document, with COBALT, you can triage the most critical vulnerabilities in 3 to 6 clicks. And we provide those 2 different ways or 3 different ways to look at the information, access it, triage it, again, driving efficiencies, driving value from the pen test for you. So again, if anyone is interested, you can just go to our website, request a demo. We're happy to have a chat on your terms, and we keep the process as efficient and direct as possible. I'm really thankful for your time. Thank you for the introduction, and I'm going to hand it back over to Chetan now. Thanks, everyone.
Thank you, David. So we're happy to take any questions in the next few minutes, if you may have. So we have a quick question that I will call out, and Joe, you can jump in to answer. Let me rephrase the question. It is, how is COBALT different from tools like Burp?
Oh, great question. And I think tools like Burp or any kind of automated scanner, which Burp actually isn't, but incorporates a little bit of that functionality in place, really does kind of clear up that misconception of buying a product or compliance out of a box or a pen test in a box versus actually having humans behind the scenes making those decisions and you know, evaluating those security controls more from a human aspect. Now, all of those scanners are built by humans that have that logic in and automated. So really what it looks at is the ability to leverage a product to as a tool for an actual live pen tester as a means of scaling the ability to, for example, crawl the attack surface or enumerate parameters within a web application. So I would say something like Burp or any kind of automated scanner or tool or script really serve as a means within a tester's toolbox to perform the testing that they need, not just the tool itself to actually do everything. I think that's a bit of a misconception, but I think that's a great question.
Thank you, Joe. So the next question is, how is ShiftLeft's runtime protection different from a WAF? Great question. I'll take this one. Typically, WAF sits in front of an application and not within it. So if an hacker is able to bypass a WAF's input filters, your application is in danger of being hacked. To further elaborate, a WAF is typically a network security device, whereas ShiftLeft technology instruments the app's runtime, gaining visibility into the entire context of the application. And the other aspect of the stark difference is WAF's rules and filters are baseline from the threat landscape and not informed of the attack surface or perhaps the evolving attack surface of the application. Hence, the WAF is typically exposed to unknown or zero-day vulnerabilities if the rules are not baselined effectively. And the other aspect of WAF is they typically mention or use that moniker that learning mode is broken at speed. And what I mean by this is if your application is deployed multiple times a day, week, or a month, there's ineffective time available for the WAF to baseline itself to effectively protect your application. So the next question is, how does ShiftLeft, or how does the name ShiftLeft, or where does the name ShiftLeft come from? Great question. The term ShiftLeft is often used in quality assurance for the past few years, but we're seeing the term used more in the world of security, meaning if we resolve security-related bugs earlier in the life cycle, there is less likelihood of loss to both the business and the data owned by the business. So we use the term ShiftLeft, or we essentially inherited that term ShiftLeft because we wanted to build a converged or a comprehensive solution that, first of all, understands the evolving attack surface of the application, and then thereby surgically protects the application in one time, and also continue to learn from runtime and inform the attack surface that is being created or baseline during the build process. So think of this as a connected feedback loop that is continuously working throughout the life cycle of your application. This is the next question that goes to Joe. Why do I need pen tests?
Great question. I think anytime you are familiar with a piece of software or your application or your product or solution or what have you, infrastructure, you have a tendency to be blinded in the sense of making assumptions on the security or assumptions that a particular use case will be followed that really kind of falls into place with the expectation or the expected result. That's why I think third-party validation or having some kind of objective third party assess the code through a pen test really makes a lot of sense, because it'll take a separate set of eyes on that solution and on that product to really exercise it in manners that it's not intended. And I think that's the key crux and hidden superpower of a pen tester and its very essence is really looking at things a little bit differently, asking some of those questions that say, hey, I wonder what this does, and then finding and noting the result. So evaluating the security on your software or your infrastructure on a frequent basis, or typically after significant changes are taken in place into that implementation, is definitely a best recommended practice, just as that safety net of sorts, to ensure that the application is still in its sound, secure state. And I also like to add in that pen tests really are a snapshot in time of the security posture of that particular environment. There's many variables that can influence the security of a piece of software, even if no code updates are applied. For example, if third-party libraries are incorporated into the site or into the product, it may, at one point there may be a vulnerability that's noted about that issue that affects your application, which now changes the state of the security of your solution. So really, it's that third-party validation and that double check to make sure that the application is as secure and sound and safe as it possibly can be. And Chetan, I also see a question in here. I believe it's for you, from Ben.
Absolutely.
Says, from my limited exposure, it looks like ShiftLeft must be source code aware. If that's true, which languages does ShiftLeft support?
Absolutely. Thank you, Joe. Yes, this question's for me. A great question, by the way. ShiftLeft is, of course, source code aware. So at the moment, we support Java and .NET, and on roadmap, we will soon be supporting JavaScript, Golang, and Python. So we don't have any more questions. So thank you, Joe and David from COBALT. Appreciate it.
Thank you very much for having us.
Absolutely.
And thanks everyone for coming.
Thank you, everyone, and you have a good day.